right, good morning, everyone. How's everyone doing today? A little toasty in here? Well, I apologize for that. I've submitted a work order for plant ops, so hopefully they'll be able to fix it remotely. Wouldn't be ideal if they brought a big old ladder in here in the middle of class, would it? Anyway, if you'll remember back to last class, I mentioned I was going to have everyone fill out a seating chart. Like I say, I apologize for having to do this. It's just really difficult to learn names when you can only see eyes. So basically, the way I've got this laid out is the podium is right here. So this is the front, and then the back is going to be back there. So pretty self-explanatory. So let's put your name right there. And if you'll put your first and last name on it, that'd be much appreciated. While that's going around, I'll also make a couple other announcements. No class Monday. Didn't get a single complaint about it, if you can believe it. I certainly believe it. I'm glad to have Labor Day. Hopefully you all are glad to have Labor Day as well. I'll take any holiday they give me, you know what I mean? They didn't even give me this one. I took it though, don't worry. Anyway, so feel free to do whatever you want on Labor Day. Also, Friday, we will meet in the lab if you're group 1 and if you're group A, whichever group's at the top. It's going to be in the lab, and then whichever group is not on the top, I think it's group B, you'll meet in here, and one of the networking team members, I believe Brian, but it could be Nick, not positive on that, will actually take you guys on a tour around campus and show you all some of the different networking equipment we have, possibly some server rooms as well. I don't really know what they're going to show you. Feel free to ask them any questions you like. They're very knowledgeable. Both Nick and Brian are both very knowledgeable. Make sure that's what they want you to call them, though. They might want you to call them by their last name. I don't know. But I'm pretty sure they'll go by first name. So, yeah, I mean, like you could ask them anything about certifications, ask them how they got their start in their career, ask them that sort of stuff, You don't have to. It's not participation. But there's professionals working in the field, both got a lot of experience. Probably be a good idea to ask some questions to them. So with that out of the way, does that make sense to everyone? So you all know which lab group you're in, right? If not, it's in Canvas somewhere. I think it's in the syllabus and schedule folder, but I'm not sure where I put it. But it's in Canvas somewhere. So today we're talking about Chapter 2, which is going to be the Open Systems Interconnection Specifications. So before I go too much into this, I do want to say, just like with last chapter, a lot of this is going to be covered in more detail in Chapter 6. This is just kind of introducing some of the stuff with the open system interconnection specifications, and we'll really cover this a lot more detail next, well, not next class, but when we get to Chapter 6. So basically, we'll be briefly introducing the internetworking models, talking about what they are and why we have them. We'll talk about the OSI reference model. That's going to be the bulk of the class today. And then we'll wrap up by talking briefly about encapsulation and modulation. So, in general, an networking model is just really some sort of a representation of how we can transfer data across a network. So, if you think about it, is it possible to just have completely different sized packets going across a network all the time? It's possible if the system expects it. What's the problem with doing that, though? Well, there's several problems. The first problem would be that there's all sorts of different sized packets. You'd have to know what the size of each packet is, so the header is going to get even longer, and it's just going to cause a lot of problems. So originally, there were different vendors like Cisco, HP. All of them had their own sort of specifications for how data would be transferred. And this is prior to 1970s. So imagine if you had a firm, and let's say whatever vendor you're with, I'm not going to mention any by name, but let's say whatever vendor you're with, you get upset by them. Maybe they raised your prices, maybe they raised your service agreement, whatever the case is. For some reason, you're upset with them. Maybe you don't like that their support went downhill. Whatever. So if you're vendor specific, you're tied in and locked into a vendor with your network, is that a good thing? Why is that a bad thing? Exactly. So you'd have to replace every piece of equipment that you had in terms of the network to be able to still communicate. Is that going to be inexpensive or is that going to be expensive? It's going to be very expensive. So in addition to it being costly, you know, how much time is that going to take? Depends on the size of the network and the number of people working on it. But in general, that's not going to be a quick thing at all. So lots of different reasons why it's good to have this not be vendor specific. So to address that, ISO developed the Open Systems Interconnection, and this just kind of allows us to have a more standardized format so that different pieces of network technology can communicate with each other, as opposed to having it be tied in to one vendor having their own rules. So one of the key tenets of OSI is using a layered approach. So think about an onion. You've all seen onions before, right? Okay. When you have the outer layer, you go in another layer. You know, it's slightly smaller, but it's still part of the onion. So it's the same thing here. Basically, we're taking all the different tasks we would do to transmit data from one computer to another computer, or I should say one host device to another host device. And we're basically layering that so that each layer does distinct tasks. And this has several advantages. The first is, let's say there's a problem with the network, and you're not receiving something that you're downloading. Well, because it's in a layered approach, you can see, are we getting it at each layer? So you just run some basic diagnostics and see, well, I can connect to my router, but the router can't connect to the internet, for example. So that'd be probably a layer 1 problem in that case. And that's one of the advantages. Another advantage is reduced loss. Now, when I'm talking about loss, I'm talking about several types of loss here. Loss of time, you're having less lost time, fewer lost packets, you know, because if you're submitting data over a network, that's going to be a very important thing, that you don't lose the packets. What happens if you have a lot of dropped packets on a network? Is that going to be a good user experience or a poor user experience? It's going to be very poor. So by having it in different layers, you're going to reduce that. Not eliminate it, of course. There's tons of opportunities. Next class, we'll talk about different broadcast media. And first lab we're going to do is actually making Ethernet cables. Now, when I say making, I mean putting ends on them. We're not actually going to go out and mine copper and whatever you got to do after that. Just going to keep it nice and simple. I've got a big spool of cable, cut off some links, and we're going to put some ends on the cable. So that's going to be the first lab. And also, because it's a layered approach, each individual layer can be controlled by whatever is going to be happening inside of it. So what that means is, if I have an application, do I need to be worried about the physical layer at all? No, because I'm only interfacing with the layer directly below me, because its application is at the top. So layer 6, that's all you need to worry about if you're building an application. So that's going to be very beneficial. And the principle behind that is the binding principle, where basically we say that the layer only communicates with the layer it's submitting information to. It's not going to be able to submit information to the physical layer if it's at the application layer. Does that make sense? Okay. So let's go ahead and talk a little bit more about the OSI. It's basically a conceptual model. If you'll look at it, which we'll see in a slide or two here, you'll see it doesn't really have any distinct, task associated. It has sort of a general concepts of what's happening, but it doesn't say this is exactly how it happens. So that allows for some flexibility, but also a good degree of standardization. So imagine if we had extremely rigid standards that did not allow for any customization at all. What would that do you think, to the innovation, to advancement of technology? Would that help it or harm it? Probably harm it. So it's a good thing to have a sort of conceptual model, but when we get into more specific standards, it's important that those are separated from the conceptual model. So that's why we have the 802 standards that are not the same as the OSI model itself. It's a beneficial way of doing things. a little bit nuanced, but basically, as we've said, this allows us to have standardization of network communication across all devices. So, imagine if Fort Lewis said, we use HP equipment for networking. You can only buy an HP computer. Would that upset anyone in here? It wouldn't be great, Maybe you like HP, maybe it wouldn't be a problem for you. Maybe you're a Lenovo fan. Maybe for Apple. Maybe you like Dell. Whatever the case is, it's a very good thing that we can have one network for all devices. So that's what OSI allows for. Now, this is where it gets kind of fun. Now, I've got a couple mnemonic devices, and I'll be honest, I didn't remember them, so I had to write them down. But this is how you could remember them if you chose to. Please do not throw away, Please do not throw sausage pizza away. Okay, it's one way. Another way is, please do not touch Steve's pet alligator. Okay, so starting at the P, it's going to be please do not touch Steve's pet alligator. Something like that. Okay, you definitely need to make sure that you memorize this for the exam. Very possibly you could see a question asking you to put them in order. I'm not saying you will, I'm just saying I wouldn't be surprised. A lot of other things could happen, but for the most part, when we're thinking about this, this is all that this is about for this chapter, basically. So, let's go ahead and get this up. So, basically, what we're going to do is kind of think about this in terms of we're starting at the application. That's going to be layer 7. Now, with layer 7, okay, is there a layer above 7? It's layer 8. What is layer 8? It's the user, person sitting between the chair and the keyboard. So, if you're an IT employee and you're talking about a layer 8 problem, what does that mean? So, user problem. Now, that's not a very polite thing to do in front of someone, because what if they know what you're talking about? Would that make them feel good? It might not, but if they did know, it's possible they might have a sense of humor about it. If I'm going to advise you on your career trajectory, I would advise against saying that in front of people. If you're talking amongst your colleagues, that's fine, probably. I'm not saying it is, but it probably is. But among, the general population, it's not a great thing. What about an ID10T error? Is that a good error to talk about? So, you guys know what ID10T is, right? Idiot. Not a good thing to say or to type. But that's what we're talking about. So, layer 8, the user. So, the user interfaces with applications. Okay, this is where they're using whatever applications they want to. Okay, the presentation layer is going to basically format whatever they're receiving from the session. So, it may encrypt, it may decrypt, whatever it needs to do. It may encode it. So, if you're typing in whatever format, it may encode it to something that the session can better use. So, the session is going to be more where we're actually sort of interfacing more directly with the different devices that we're using. So, this is where we're talking about the logical ports. So, you've got like port 8080, for example. Whatever ports you're using, port 443. It's going to be the session. It's going to be unique to each of the different applications that you have, and each application can have multiple sessions. So, for example, if you have a web browser open, as you know, you can have multiple tabs going. Each of those tabs are going to have a unique session. Okay, now this is where it gets kind of a little more interesting. So we're talking about the transport layer. This is where the machine really recognizes the sort of connection between it and the greater network. Okay, so the network itself, that's going to handle the routing. So when we're talking about that, we're really talking about the different IP addresses. So it's going to go to the router, basically. Data link, of course, it's going to be for framing. It's going to be the MAC address. It's going to go to the device. And then lastly, the physical link, it's going to be the actual physical connection there. So just kind of a brief little thing there. In fact, let me go ahead and write these layers on the board. So we're probably going to do an exercise with them. So application, presentation, session, transport, network, data link, physical. Like I say, important that you have those memorized, have a basic understanding of what they do. You don't have to know every single part about them, though. So now let's talk about the upper layers a little bit. So as I said, got the application, presentation, and the session. So this is going to happen on the individual host device. So if you all are using computers, maybe some smartphones right now, all happening in the upper layers. So the application, pretty self-explanatory, is what you see. Okay, so it's a user interface, whatever application you're using. That's what we're talking about there. Presentation is getting the data ready for the application. So, like I said, we just talked about the encryption. We talked about the encoding, decoding, anything like that. Session, just making sure that each of the individual applications or even parts of the application can't see other parts of it. That's all happening on the local device. So I like to kind of think about this in terms of the technology it's actually using. So for example, if we're using a web browser, the application is going to be using HTTP. Okay, the presentation, assuming it's going to be using SSL. Okay, and then the session, like I said, it's going to be that logical port. So for HTTP and SSL, probably going to be 8080 and 443. We'll talk more about those logical ports in later chapters, but for now, does that kind of make more sense to kind of think about it in those terms? Because, you know, reading this and seeing what it means, actually think about the technologies behind it, I think that's an easier way to think about it. So that's what we're talking about there. And next we have the lower layers. Like I said, this is where we're actually sending the data off the machine. So the transport layer is kind of like that go-between. It's sort of that intermediary where it's basically receiving it from the router and then giving it to whichever process it needs. So that's going to be like the TCP, which we're going to talk about in, I think, chapter 6. The network is going to provide the logical addressing. So it's going to route all the different packets where they need to go. And that, of course, is going to be the IP address. So each router, of course, is going to have an IP address. And it's basically happening there. Data link, like I said, important thing here, the MAC address. Okay. And then lastly, we're going to talk about moving the stuff physically. So that's the actual, you know, physical connection there. So just kind of went over that twice. Everyone got it? Like I said, this is the most important thing in this chapter. Everything else is covered later. So, who wants to be brave and volunteer? I need 7 volunteers. All right. Well, come up here, I'll tell you. So, volunteer. 5 more. It's okay. All right. 4 more. 3 more. So we got 4. 3 more people. 2 more. 1 more. Just 1 more person. Appreciate it, guys. All right. So we're going to actually just kind of talk about what these are. So we're just going to go down the road, and I'm the end user. We've got the application, the presentation, session, transport, network, data link, and physical. Okay. So we're going to talk about what a message would be. So imagine I'm typing in, let's say, Google Docs, and I'm typing something like, I really love networking technology. Okay. So that's going to go to the application layer, and you're going to write up there what that message would be. So I think the blue marker, yeah, it works. So you just literally type the message for you and by the application. I really like networking technology, just something like that. Okay, so now you are going to present it. So maybe you encrypt it, maybe you encode it. You can just write encrypted or encoded in the message. Encrypt it as well, and then write out the message. All right, so now for the session, what are we going to do for the session? All right, so we know that the session is going to keep each of the different applications' data separate. So that's where we're going to basically put a header on it that says which application it is. So you can just write like web browser. If you want to write a specific web browser, that's cool. Yeah, whatever's on the presentation as well. Everything. All right, thank you. Now we're going to go to the transport layer. Okay, so what's one thing that happens in transport layer? Well, you know, basically goes from the computer to the network as a whole. So to do that, what's one thing we have to do? Exactly. So we're going to put that into different packets. So let's see. Let's shorten that a little bit. And maybe the first packet can be I really like. Second packet can be network technology. Make sure you include a header where it's going. Oh, just put a random IP address. IPv4 preferably. I won't be here all day writing IPv6 addresses. Yeah, that works. So for the network layer, it's going to be very similar. We're just going to make sure we have the logical addressing, which I think we just included with the transport. So just write the same thing. It's not actually quite the same, but just make sure we have a header on it. That's what they're doing there. Basically. And of course, this is a simplification of what's happening, but just want to have some sort of visualization of it as well as kind of conceptually understanding it. That would probably be the network. Because at that point, it's going to the router. All right, so now for data link, we start writing some ones and zeros there. I mean, basically, it's, getting it in to be ready to go to them. And you also put the MAC address before it as well. Because we're getting into bits and bytes and stuff, so. Don't forget about the MAC address. No, the MAC address is going to be 6. What is it called? It's 6 duplex 0 through 9, A through F, I think. So it'd be like, for example, 0A, 2B. Now you're going to want to put a colon in between those. So it's like pairs of 2. Yeah, exactly. So just make up stuff. You guys know what a MAC address is, right? It's media access control. It's specific to a network interface card, or should be specific to a network interface card. They can technically repeat, especially with less than reputable manufacturers of hardware. Looks like you need one more, because it's a total of 12 characters. 6 pairs, basically. Good enough. And now for the physical. So we're actually going out onto the actual connection itself. So you could literally write lines if you wanted, I mean, you know. I mean, like, you could literally just do, like, you know, like this, because it's physical. So basically what's happening in a nutshell. It's a simplification, of course, but that's the general gist of everything. Does that make sense? All right, thanks, guys. So, any questions about it before we move on? Yeah, basically do pretty similar things. It's just one of them's going from the computer, and the other's going to the network. So, all right. Now we're going to talk about encapsulation. So encapsulation is basically happening in that transport layer. In fact, most of the stuff happens in that transport layer. It's a very important layer. So this is where we also have the SYN, synchronize, acknowledge, synchronize, acknowledge. That's basically what we're having happen there in this. So as you can see, we have the upper layer data. And first thing we're going to do is we're going to convert that user data, user info into data. Okay, once we've done that, we're going to convert it into segments. So we're going to apply the header to it for the TCP, which we're going to talk about in Chapter 6. Apply the IP header, add the IP address, the LLC header, the MAC header, and then, like I said, we end up with binary. So basically, you know, this whole process is encapsulation. Most of it happens in the transport layer. So like I said, this is going to be covered in a lot more detail in Chapter 6, but for now, just kind of conceptually understand it's a very important layer. Does that make sense? So basically, it's taking information from the higher layer, which is going to be, you know, at the end result, if we go all the way to the top, it's going to be the application layer in layer 7. And it's going to add a header to it, treating a higher layer information as data. So instead of having a whole big string of information, it's going to break it down into bits of data. Does that make sense? So that's the whole process of encapsulation. And like I said, we go from packets to frames and from frames to bits. So that's not really going to be the focus of the class. I'm going to ask a test question. Probably going to ask you more about the order and the general stuff of what's happening. You know, in Chapter 6, we'll cover this in a lot more detail. So then we also have the protocol data units, which are going to be used by each of the different layers. And the whole purpose of them is they start, as you can see, they go down from the application all the way down to the physical. Okay? And basically, this just kind of attaches the data to it. And usually we're going to put this information in the header and footer once it exists. So as you can see, we're not going to have it until we go down to the packet layer, because that's where we actually add in that header. So that's basically what we're doing here. And of course, I should also note that this is a two-way street from application to physical and physical to application. So if you're sending data, which way is it going to go? So it's going to go from application to presentation, session, transport, network, data link, physical. let's say someone is sending you data. How's it going to get to you once they've sent it? So it's going to go from physical to data link, to network, to transport, to session, to presentation, to application. So this is not like it only goes one way. Of course, it goes both ways. Does that make sense? Okay. Just want to make sure that was clear. Talk a little bit about modulation. So modulation, as the name would imply, it's going to happen in that physical link. And it doesn't always happen. So basically, this is converting digital to analog. And let's say we have a fiber connection. Is that going to need modulation? So first of all, let's back up. Is fiber digital or analog? So it's going to be digital. So because it's digital, we don't need a modem of any kind in a fiber connection. Say we have copper of some sort, be it some sort of cat cable, or maybe it is a coaxial cable. Are we going to need a modem in that case? Or even DSL? Definitely, because it's going to come in as an analog, we got to convert it to digital so our equipment can understand it. And whatever we're sending out has to go from digital, which is what it was on the network, to analog to be able to go across to the physical connection. So we have something called a modulator, demodulator. Basically, that's what a modem is. Well, it is literally a modem. So what we're doing is we're going from analog to digital, from digital to analog. And modem can do both of those things by the name, modulator, demodulator. So that's going to be used for any DSL connection. That's going to be used for any cable internet connection. And that's basically what we're using. So this is going to happen in which layer? Physical, exactly correct, because this is where the ISP comes in, basically. So it's always going to be on the physical layer. Okay? Does that make sense to everyone? Okay. So like I said, we're going to cover this a lot more in Chapter 6, but for now, just want to kind of introduce some different networking models, cover the OSI reference model, and also touch a little bit on encapsulation, and just basically say what modulation is. Any questions about today? All right, well, that's it. Hope you all have a great day. I will see you all Wednesday. And did everyone sign the seating chart? All right. Thanks, guys. So that's going to be Friday. Next Friday. So you know which group you're in, right? Gotcha. So if you're group A, you're going to be meeting in the lab. If you're group B, you're going to be meeting here. Gotcha. No class Monday. Have a good weekend, everyone. Who is? Yeah, so you'll meet in here. Like I was saying, basically the networking team is going to come by, and they're going to take you guys on a tour of all the different, or some of the different data distribution and stuff like that. No class Monday. It's Labor Day. Yeah, you too.